She put on her latex gloves. She picked up the dropper. 2 drops of dimethylmercury fell onto her gloved hand. She wiped them off. She continued her work. 5 months later, she started slurring her words. 6 months later, she couldn't walk. 7 months later, she was in a coma. 10 months later, she was dead. Karen Wetterhahn, 48 years old, professor of chemistry at Dartmouth College, one of the leading experts on toxic metal exposure in the world. She knew mercury was dangerous. She took every precaution. She wore protective gloves. She worked in a fume hood. She followed every safety protocol that existed in 1996. It didn't matter. 2 drops of dimethylmercury soaked through her latex gloves in less than 15 seconds. The mercury entered her bloodstream. It crossed into her brain, and it destroyed her from the inside out. By the time she showed symptoms, it was too late. There is no cure for mercury poisoning at that level. She died knowing exactly what was happening to her brain and being powerless to stop it. This is the story of how one of the world's top chemists was killed by the substance she spent her career studying. And this is why every chemistry lab in the world changed its safety protocols after August 1997. This is the blood law written in the body of a scientist who did everything right and died anyway. Hanover, New Hampshire, Dartmouth College, one of the most prestigious research universities in America. Karen Wetterhahn had been a professor there since 1976, 20 years. She ran the Toxic Metals Research Laboratory. Her specialty was studying how heavy metals like mercury, lead, and cadmium affect living cells, how they enter the body, how they bind to proteins, how they damage DNA, how the body tries to excrete them. She had published over 80 research papers. She was recognized internationally as an expert in her field. She trained graduate students. She mentored young scientists. She was respected, brilliant, careful. She knew toxic metals better than almost anyone alive, and that knowledge is what killed her. Mercury is one of the most dangerous substances on Earth. Humans have known this for thousands of years. Ancient Chinese alchemists died from mercury poisoning. Hat makers in the 1800s went mad from mercury used in felt processing. That's where the phrase "mad as a hatter" comes from. Mercury poisoning causes tremors, memory loss, personality changes, kidney failure, and death. There are different forms of mercury. Elemental mercury is the liquid metal you see in old thermometers. It's dangerous if you breathe the vapor, but relatively safe if you touch it briefly. Inorganic mercury salts are more toxic. They can be absorbed through skin. Organic mercury compounds are the most dangerous. And the most dangerous organic mercury compound ever created is dimethylmercury. 2 methyl groups bonded to 1 mercury atom. It was synthesized in laboratories in the early 1900s. Scientists quickly realized it was incredibly toxic. A few drops could kill you. It absorbs through skin instantly. It crosses the blood-brain barrier. It accumulates in the brain. It causes irreversible neurological damage. By the 1970s, most chemists avoided working with it. It was too dangerous. But some research required it, studying how mercury binds to proteins, studying how cells process heavy metals. That research required pure dimethylmercury. That's what Karen Wetterhahn was doing in August 1996. She was studying how mercury interacts with DNA repair proteins. Specifically, she was looking at how certain proteins bind to mercury and either protect cells or make the damage worse. To do that research, she needed to expose protein samples to dimethylmercury. She needed to measure the binding. She needed to analyze the results. It was delicate work, dangerous work, but it was her expertise. She had worked with toxic metals for 20 years. She knew the risks. She took precautions. She worked in a fume hood, a ventilated chamber that pulls dangerous vapors away from the researcher. She wore a lab coat. She wore safety goggles. She wore latex gloves. Latex gloves were the standard protective equipment in 1996. Every chemistry lab used them. They protected against most chemicals. They were cheap. They were comfortable. They were what every safety manual recommended. Karen Wetterhahn put on her latex gloves, picked up a small vial of dimethylmercury, and began transferring it to her protein samples using a dropper. August 14th, 1996, sometime in the afternoon. She was working alone in her lab. She was using a pipette to transfer tiny amounts of dimethylmercury from a vial to test tubes. She was being careful, slow movements, steady hands. Then something happened. Maybe her hand slipped slightly. Maybe the pipette dripped. Maybe the vial tilted wrong. 2 drops of dimethylmercury landed on the back of her left gloved hand. 2 drops, maybe 3, a tiny amount, less than half a milliliter total. She noticed immediately. She stopped what she was doing. She carefully set down the vial and pipette. She peeled off her gloves and disposed of them properly. She washed her hands thoroughly, soap and water, multiple times. She followed every decontamination protocol. She documented the exposure in her lab notes: minor spill, gloves protected skin, hands washed, no concern. She went back to work. What Karen Wetterhahn didn't know, what nobody knew in 1996, was that dimethylmercury soaks through latex in 15 seconds. Latex gloves provide zero protection against dimethylmercury. The chemical passes through the material as if it's not there. The 2 drops that landed on her glove passed through the latex, contacted her skin, and absorbed into her bloodstream in less than 20 seconds. By the time she took off the glove and washed her hands, the mercury was already inside her body. Washing did nothing. The damage was done. 150 milligrams of dimethylmercury had entered her system. That's enough to kill 5 people. She had no idea. For the next 4 months, Karen Wetterhahn felt fine, completely normal. She taught her classes, she ran her lab, she mentored graduate students, she worked on research papers, she went home to her husband and family. Nothing seemed wrong. Mercury was accumulating in her brain the entire time. Dimethylmercury is lipophilic. It dissolves in fat. The brain is 60% fat. Dimethylmercury crosses the blood-brain barrier easily and deposits in brain tissue. Once it's there, it undergoes a chemical transformation. It converts to methylmercury and then to inorganic mercury. Inorganic mercury binds tightly to proteins in neurons. It doesn't leave, it accumulates, and it destroys brain cells, slowly and irreversibly. This process takes months. You feel nothing while it happens, then suddenly you feel everything. January 1997, 5 months after the exposure. Karen Wetterhahn started noticing small problems. She was forgetting words mid-sentence. She would be teaching a lecture and suddenly couldn't remember a chemical term she had used for 20 years. She would be writing an email and forget what she was trying to say. She thought it was stress. She thought she was working too hard. Then her balance started going. She would trip over nothing. She would reach for something and miss. Her husband noticed she was walking differently, unsteady, like she was dizzy. She saw her doctor. The doctor ordered basic tests, blood work, neurological exam. Everything came back normal. The doctor suggested she was fatigued. Take some time off, get more sleep. She tried. It got worse. February 1997, 6 months post-exposure. Karen could barely walk. She needed help getting out of chairs. Her speech was severely slurred. She couldn't form sentences properly. Words came out garbled. Her vision was blurring. She was having trouble focusing her eyes. She went back to the doctor. More tests, MRI, CT scan, blood work again. This time they found something. Her mercury levels were off the charts. The blood test showed mercury concentration at 4,000 times normal. The doctors were shocked. How did a chemistry professor get exposed to that much mercury? They asked her if she had been eating a lot of fish. Mercury accumulates in fish. But even eating fish every day for years wouldn't produce levels this high, Karen thought back. She remembered the spill. August, the 2 drops on her glove. She told the doctors. They didn't understand. She wore gloves. How did mercury get through gloves? The doctors started treatment immediately. Chelation therapy, chemicals that bind to heavy metals and help the body excrete them. Dimercaprol, penicillamine. They pumped her full of chelating agents, hoping to pull the mercury out of her system. It didn't work. The mercury was bound to proteins in her brain. Chelation can remove mercury from blood and organs. It cannot remove mercury that is bonded to brain tissue. The damage was permanent, and it was spreading. Her condition deteriorated rapidly. March 1997, 7 months post-exposure. Karen Wetterhahn could no longer walk. She couldn't speak. She couldn't feed herself. She was confined to a hospital bed. Her husband stayed with her constantly. Her colleagues visited. Her students came to say goodbye. She was still conscious. She could hear. She could understand what people were saying, but she couldn't respond. She couldn't move. She couldn't communicate. She was trapped inside a body that was shutting down, and she knew exactly what was happening. She was a neurotoxicology expert. She knew how mercury destroys the brain. She knew the progression of symptoms. She knew there was no cure. She knew she was dying. She could do nothing but wait. The doctors did more tests, another MRI. The images showed catastrophic brain damage. The cerebellum, which controls movement and coordination, was almost completely destroyed. The visual cortex was severely damaged. The motor cortex was failing. Her brain was dissolving from the inside. The neurologists had never seen mercury poisoning this severe in someone who was still alive. They documented everything. They wrote case reports. They knew this was going to be studied for decades. A world expert in mercury poisoning killed by mercury while following all known safety protocols. How did this happen? They started investigating. They ran tests on latex gloves. They exposed latex gloves to dimethylmercury. They measured how fast it penetrated. 15 seconds. Dimethylmercury soaked through standard latex gloves in 15 seconds. They tested nitrile gloves, also useless. They tested vinyl gloves, also useless. Every standard glove material used in chemistry labs in 1997 provided no protection against dimethylmercury. The only material that provided adequate protection was laminated polymer, thick multi-layer gloves that almost no lab stocked because they were expensive and cumbersome. Nobody knew latex gloves were useless against dimethylmercury because nobody had tested it. The assumption had always been that gloves protected you. That assumption killed Karen Wetterhahn. June 8, 1997. 10 months after the exposure, Karen Wetterhahn died. She was 48 years old. She left behind a husband and 2 children. She left behind 20 years of research. She left behind dozens of students she had mentored. She left behind colleagues who respected her. She left behind a chemistry department that was devastated. One of their best professors had died doing her job, following safety protocols, wearing protective equipment, and it hadn't mattered. The funeral was held at Dartmouth. Hundreds of people attended, students, faculty, scientists from around the world who had worked with her. Everyone wanted to know how this happened. How did someone so careful, so knowledgeable, so experienced die from a chemical she knew was dangerous? The answer was simple and horrible. The safety protocols were wrong. The protective equipment didn't work, and nobody had bothered to check until it was too late. Dartmouth College launched an immediate investigation. They tested every chemical in every lab. They tested every type of protective glove against every toxic substance they used. They found dozens of combinations where standard gloves provided inadequate protection. Dimethylmercury wasn't the only chemical that soaked through latex. There were others: organic solvents, strong acids, certain bases. Chemists had been working for decades assuming their gloves protected them, when in many cases the gloves did nothing. Dartmouth rewrote all their lab safety protocols. They banned certain chemicals from being used unless absolutely necessary. They required specific types of gloves for specific chemicals. They required double gloving for highly toxic substances. They required real-time monitoring of researchers working with dangerous materials. Never work alone. Always have someone watching. Always have emergency procedures ready. They installed better ventilation systems. They improved training. They made Karen's death mean something by making sure it never happened again at Dartmouth. But Dartmouth was just one university. There were thousands of chemistry labs around the world, in universities, in pharmaceutical companies, in government research facilities, all using the same inadequate safety equipment, all assuming gloves provided protection. Karen's colleagues published her case in medical journals. They published in chemistry journals. They published in safety journals. They wrote to every major university. They wrote to OSHA. They wrote to the American Chemical Society. They wrote to the National Institutes of Health. They wrote to everyone who would listen. The message was clear. Your safety protocols are wrong. Your gloves don't protect you. People are going to die if you don't change this immediately. The chemistry community responded. Within 6 months, every major university in America had revised their chemical safety protocols. The American Chemical Society published new guidelines for handling highly toxic compounds. OSHA updated workplace safety regulations for laboratories. The National Institutes of Health updated their guidelines for research involving toxic metals. New requirements were established. Any researcher working with highly toxic compounds must use silver shield gloves or laminated polymer gloves. These gloves are thick, difficult to work with, and expensive, but they actually provide protection. Researchers must double glove, inner nitrile glove plus outer silver shield glove. If the outer glove is contaminated, remove both gloves immediately. Never work alone with highly toxic materials. Always have a partner present who can call for help if something goes wrong. All work with highly toxic materials must be done in a fume hood with proper ventilation. Labs must maintain detailed exposure logs. If any chemical contacts skin, even through gloves, it must be reported and the researcher must be monitored. Blood tests, neurological exams, follow-up for months. These became standard practice in every research lab. But the changes went further. Universities started questioning which chemicals they really needed. Did researchers actually need to use dimethylmercury? In most cases, no. Substitute compounds could be used that were less toxic. Dimethylmercury was removed from most labs entirely. Only essential research requiring it was permitted, and that research required approval from safety committees. Training was overhauled. New graduate students in chemistry programs now spend weeks learning chemical safety before they ever enter a lab. They learn which chemicals penetrate which glove materials. They learn exposure symptoms. They learn emergency procedures. They learn that following the rules isn't enough. You have to understand why the rules exist and what happens when safety equipment fails. Karen Wetterhahn's case is taught in every chemistry program in the world. Students watch videos about her death. They read her case study. They learn exactly how she died and why. The goal is to make sure every chemist knows that protective equipment is not foolproof. Know your chemicals, know your gloves, know the risks, and never assume you're safe just because you're following procedures. The medical community learned from her death, too. Karen's doctors published extensive case reports documenting the progression of her mercury poisoning, the timeline, the symptoms, the test results, the brain imaging, the failed treatments. That documentation became the definitive reference for mercury poisoning diagnosis and treatment. Emergency room doctors now know what severe mercury poisoning looks like. They know the tests to order, they know the treatments that work and the ones that don't. They know that once mercury is in the brain, it cannot be removed. The only treatment is prevention. Catch it early, before it crosses the blood-brain barrier. After that, there's nothing medicine can do. Karen Wetterhahn's husband, Joseph, became an advocate for laboratory safety. He worked with universities to improve protocols. He spoke at conferences. He pushed for better funding for safety equipment. He made sure people remembered why these rules existed. His wife died because safety equipment failed. She did everything right. She followed every rule. And she died anyway. The rules were the problem. The equipment was the problem. The system was the problem. And he made sure the system changed. He didn't want anyone else to get the phone call he got. Your wife is in the hospital. She has mercury poisoning. There's nothing we can do. She's going to die. No other family should go through that. Today, every chemistry lab has detailed chemical-specific safety protocols. You cannot work with highly toxic compounds without specialized training. You cannot work with certain chemicals without specific glove types. You cannot work alone. You cannot skip safety checks. Labs are inspected regularly. Violations result in immediate shutdown. These are federal regulations. OSHA enforces them. Universities enforce them. Companies enforce them. Because Karen Wetterhahn died and the chemistry community decided it would never happen again. Every protection that exists in modern chemistry labs was written after her death. Every glove requirement, every training protocol, every monitoring system. All of it came from studying how she died and making sure those conditions never existed again. There is a memorial at Dartmouth College, a plaque in the chemistry department. It has Karen Wetterhahn's name. It lists her accomplishments, her research, her teaching, her mentorship. And it says she died from dimethylmercury exposure in 1997. It reminds every student who walks past it that chemistry is dangerous. Chemicals can kill you. Safety protocols exist because someone died without them. Respect the chemicals. Respect the protocols. Respect the people who came before you and paid with their lives to make your work safer. Karen Wetterhahn spent 20 years studying toxic metals. She published groundbreaking research on how heavy metals damage cells. She trained dozens of students who went on to their own successful research careers. She was one of the top scientists in her field, and she was killed by the things she studied because the safety equipment everyone trusted turned out to be useless. The next time you see a chemistry lab, think about the gloves. Those thick, awkward, expensive gloves that chemists complain about. They exist because latex gloves failed Karen Wetterhahn. The next time you see a sign that says never work alone, remember that Karen was alone when dimethylmercury soaked through her gloves. The next time you see detailed chemical safety protocols that seem excessive, remember that Karen followed all the protocols that existed in 1996 and it wasn't enough. She died so those protocols could be rewritten. She died so future chemists would know which gloves actually provide protection. She died so labs would test their safety equipment instead of assuming it worked. That's what a blood law is. Someone does everything right and dies anyway. Then we figure out what went wrong and change the rules so it never happens again. Karen Wetterhahn's death rewrote lab safety for the entire world, and every chemist working today is safer because she died.